this is Ken Jackson. Ken is currently the director of critical infrastructure at Zayo, and Ken has been in the data center market for over 25 years. So he's going to give us an insight into where he believes the future of data centers are. So hi today, Ken. You okay?
I'm doing well. I'm doing well. Thank you. Thanks for having me.
Perfect. No worries at all. Great to hear your story, and like I said, really intrigued to hear your background and where you feel like the market is going to head to over the coming years. So, do you want to tell me a little bit about yourself, Ken, and your kind of experience in the data center industry to begin with?
Sure. So, back in 2000, after I exited the U.S. Navy, did electronics and electronics engineering in the Navy. And I came out, I ended up with an organization called the IBEW, the International Brotherhood of Electrical Workers. It's the electricians union. And so I
Yeah.
went through the apprenticeship with the electricians union, and that's where I was introduced to a data center. And I got my first taste of a data center, and I knew immediately it's what I wanted to do. And from that point, I ended up leaving the electricians union after getting the training, and I ended up specializing in data centers. I worked for a number of different data centers. I was electrical subject matter expert in CBRE. Well, CBRE had the contract for Regions Bank and their data center, and I've worked through AMD. I was a senior, what exactly was the title? A senior facilities engineer for North American critical environments at AMD. I was a data center engineer and program manager for Hewlett Packard. Been a data center manager, led operations for Tier Point, a co-location facility. I ended up at NTT where I was director of I can't remember the exact title, but it was basically the same thing, director of critical infrastructure for NTT, their fiber division, their global fiber footprint. And now I'm over here at Zayo, and that's 25 years in 25 seconds, right?
Yeah. Great
Yeah.
background, and you've probably seen the market evolve more than most. You're probably one of the veterans of the space, so to speak. So I suppose, like, how do you feel like data centers have changed over the past 5, 10 years? We've seen the explosive growth where they are today, and but how do you feel like they've changed over maybe the last 5 or 10 years?
Sure. Well, so, most of us in the industry, we can open our LinkedIn page and we're connected to all these different news outlets or press release outlets. And you can see that every single day, some other company is announcing a new data center build, whether it be in California or Reno or Virginia or Texas. Virginia and Texas are kind of our hot spots right now.
Yeah.
Um, Folks no longer announce a 50,000 square foot, 2 megawatt data center. Like that's just a thing of the past, right? So all the press releases today are a million square foot, 3 million square foot, 5 building campus for just gigawatts of power, hundreds of megawatts and even gigawatts of power now. When I first started in the data center industry, we had 1, 2, 3 kW racks, and we would see so if you saw a 3 kW rack, that was a heavy duty rack, and now 150 kWs in a rack all day long.
Yeah,
You
yeah.
you step into one of these hyperscalers or one of these AI factories. It's incredible when I think about how far we've come in, even just over, say, 5 to 10 years. 5 years ago, we were talking about 50 kW racks, and I saw one or two. Now they're prevalent. Now they're everywhere. And
Yeah,
it's
yeah.
just unreal the amount of power and the amount of heat. Most folks think about the power, they don't think about the heat that comes with that power.
Yeah.
So
Yeah,
that's
yeah.
what I've seen.
Yeah, I think the size and scale is just kind of off the scale, now, isn't it? Like you said, things are just evolving so quickly, and the speed, like you said, of these facilities being built is incredible. But like you said, it's just 10x over the past 3 or 4 years,
Yeah.
hasn't it? Yeah,
Yeah.
yeah.
Well,
And
I see companies. Oh, I'm sorry. Go ahead.
go on. No, no.
I see companies like Compass Data Centers. They've really done a good job of um, standardizing their builds. So not only are they building at these scales, they're building fast. Man, they're turning these buildings way faster than you could ever imagine.
Yeah, and I think that the reason is ultimately the technology is evolving so quickly that you have to, it's almost like you have to be thinking of where the technology is going to be in 18 months before you've actually built the facility. And I think that's obviously the reason, we're trying to turn these facilities around so quickly. But there's obviously challenge within that, which I'm sure we'll talk about. So
Yeah, yeah.
leads us on to, what are the, one to two problems that you see in the industry today?
So, obviously, 5 years ago, 10 years ago, the number one problem was labor. But as we just kind of talked about, that number one problem has shifted to power. When you're going to build a facility or retrofit or augment a facility, getting the power to do so. So labor is still a huge, huge issue. Uh, but now getting power to your site is really the big problem because the reality is that there is no 10-year-old kid. They're still saying, I want to be an astronaut, I want to be a policeman, I want to be a fireman. These folks don't know what data centers are.
Yeah.
And so there is no career path that leads to what I do as working in the facility side of the data center. uh, One of the main challenges is just people finding out about us. I do so much to try to tell people what a data center is because everybody knows what an IT person. They know that there's a security person and there's a network person and there's a system admin. Nobody knows that there are building engineers that supply the power and the cooling. Folks just don't know about that, and that's a
Yeah.
huge problem for us.
Yeah, I think I often talk, we've done many episodes, and it's one of the key things that comes up is like we have to find a way to educate, the next generation, but also the current generation of what a data center is, and because we all need them, right? Everyone uses a data center every single day in their life, don't they? But probably don't realize that they're using it.
Yeah, your
Yeah,
bank for one.
yeah,
You check your
yeah.
bank account.
Yeah, exactly. Working from home, how like etc. It's like so. It's But have you found like do you think the shift has gone labour to power over the past 5 years as the biggest challenge? Would you say?
Well, um, that's one of the main issues is that we've
Yeah,
shifted from labor to power. Now that's in the new builds, right? So when you think about new builds, now when you start to think about legacy data centers that are already up and running, they are not so much worried about power because they're already built, they're already running, right? So their problem, their number one problem, still largely remains labor
yeah.
because finding folks, finding electricians and plumbers and HVAC techs, and then more importantly, finding one person that can do at least scratch the surface on all of those.
Yeah, yeah. Well, obviously, we make no bones about we're a staffing agency, and we see it firsthand, right? The shortage in the market, beggar belief, like ultimately, and everyone's trying to compete for the same people. So,
Mhm.
it's that old demand and supply. That there is genuinely more demand for the skills than there is supply, so that drives price up. So it just everything then is driven up because the labour cost is more. Everything then increases in terms of price, but as the market continues to evolve, we're still going to need labour. So how do we ensure the labour problem? Because it's not been fixed from 5 years ago. If anything, for me, it's got worse.
It's getting worse.
So how do we fix that? We have to be educating the next generation, or people who are in work and want to explore a new career. How do we get them to
Yeah.
to see what a great career the data center market can offer?
Well, I've thought about two different things. So, I'm from a small town called Gallatin, Tennessee, and I live just down the road. And I had always told some of the folks that I went to high school with, went to school with, they're still in my hometown and they're, teachers in the middle school and the high school. And I've reached out to some of my old friends and say, hey, if you folks have a career day, let me know. I would love to come to a career day at the local high school and tell folks about data centers. Just tell these youngsters about data centers, about how they can go to a trade trades are one of the ways that we pull people into this industry,
Yeah.
about how they can go to a trade as opposed to going to college with a 4-year degree in IT or IT management, and how they could kind of just come work on my side of the fence, through the trades or whatever the case may be. Now, coincidentally enough, I'm come from Gallatin, and so I'm still kind of involved in the community. And there was this one day, there was this city council meeting, and they said, "Hey, there's this data center this company that wants to build a data center here in Gallatin." Now, this has been, like 5, 6, 7 years ago, right?
Yeah.
When this happened, and so I'm like, huh, I'm like Gallatin of all places, like middle of nowhere, Tennessee. And so I went to the city council meeting, and they had this Project Wool Hawk, right? They had like super secret, right? Super secret squirrel stuff. And
Yeah.
they said, this is the company's rendition of the data center. And it was a classic H design. And I was like, oh, that's Facebook. And this guy looks at me and says, how do you know that? I've been I've done this on 4 continents, dude. I have literally assessed data centers all over the world, and there's only one company on planet Earth that builds a data center like that. I've
Yeah.
been there, done that, right? And
Yeah.
he got all
Yeah.
mad at me. But we now know, because it was a project, and it came to fruition, and they're there. And I say that to illustrate that Facebook, Meta, they have actually, given grants and donations to the local school system to try to educate some of these kids on, STEM, and hey, this is what a data center is. Now, obviously, Facebook is not in every community, right? But they're in my community, and I have seen the efforts where they have tried to, partner with the local school system, school board, because when you have a built-in labor force, you can educate these kids.
Yeah.
and
Yes.
and it, even if you don't go to work for Facebook, if you know what a data center is and you have, things going on. And another step that I took to bring folks into the trade is, I've been so frustrated with hiring that one day about a year ago, I sat down and I said, what am I, how do I work through this? And I thought, well, what about all these people that are exiting the military, like I did once, or don't know anything about this? And I wrote a course. I wrote a course on everything that you would need to know to go from I've never heard the word data center to I can be functional on day one. Now, I've got about an 80-page outline of all my notes and pictures and stuff of what I could just give to someone. And I have no idea what to do with it. I think I'm just going to make videos and put it on YouTube for free.
I think, yeah, I think it's just I think the trades, like, inherently are deemed as a almost a second tier career. They have been, but I think that's in my opinion, financially haven't paid as well as tech roles, etc., and things like that. So it's almost been like, right, well, if you can't do something else, you go into that. Now, I think the great thing that data centers has given, they're overtaking tech salaries.
Mhm.
Like some of the, the packages in electricians are being offered now, and HVAC engineers is marvelous for the industry. And I think once people understand they can earn a lot of money in the industry, I think that, hopefully, and we can get the message out to colleges, schools, etc. I think the industry then that is how we're going to enable the next generation to understand what a data center is. Yeah, if that makes sense.
Well, when I was a young man in high school, go to college. That's just what everybody told you. Go to college, right? Well,
Yeah,
unfortunately, college is not for everyone. And I ended up in the military, and then I came home and I went to trade school. And the reality is that trade school was kind of looked down upon.
yeah.
But in hindsight, you got $100,000 worth of debt, and you make 60, $70,000 a year, and that dude has no debt and makes $100,000 a year.
I know, I know. It's just that because that's the way society is. It's just stereotype, right? You go to college, you have to go to
Mhm.
be, get the best job, etc. You don't anymore. I think that's like I said, the industry, one of the things it's not short of is finance and cash. So I think ultimately that is a way to maybe position it as a really prevalent career for the future generation. At least I hope anyway. But
Yeah.
I think, like you said, educating them, doing I know we spoke about the offline about doing some sort of YouTube demonstration. Again, it's down to every single person in the industry that's been in it a long time to try and think we've got to leave the industry better today than when we joined. Do you know what I mean? So if everyone had the same kind of ideas as you, that's the way we can especially around labor, right? That's the way we can maybe challenge the labor shortages.
Yeah,
At least
yeah,
that's
yeah. And that's
my
the only
view
way I
anyway.
know how to fix it.
Yeah, yeah, yeah. Because I think all these companies, Meta, you see it all the time. Microsoft, they're all obviously doing a lot of these, invested in trade schools and things like that in local communities. But it needs people to actually go to them and ultimately want to be in the trade, doesn't it? So I think that's probably the message before they go into the trade school. But I suppose that moving on, like, I suppose like there's obviously many risks in the industry that people talk about, but what do you feel like the risks in the industry that isn't talked about enough? Yeah, day to day.
Here's a great one that, so from the data center industry, and currently I'm at Zayo. We're a fiber optics provider. And before that, I was at NTT, specifically the global IP networks portion of NTT.
Yeah,
And so for the past, probably 5, 6 years, I've been involved in interconnectivity between data centers.
yeah,
And so we talk about labor, we talk about power and grid, and then here later we can talk about nuclear power and whatnot. But those are the ones that everyone's talking about. Here's what no one really talks about. As we recently interfaced with NVIDIA, and not recently, we've been interfacing with them for years. But when interfaced with them, looking at the latest and greatest that they're putting out, and everyone knows NVIDIA owns the GPU market, the AI market, right? Well, when you look at what they're putting out, and I've lost track of all their code names. The various like this pod and this technology and this architecture. The last one we saw was a pod of, I want to say it was like 6 racks, and it had 16,000 fiber jumpers inside of that rack, inside of that pod of
wow,
racks. And so when we start thinking about so you're not going to just put one pod in a data center, right? You're going to put, 20 pods, 50 pods, 100 pods in a data
yeah,
center. And now, obviously, you're not going to have 16,000 times 100 fibers leaving that data center. You're gonna use multiplexers and switches and all kinds of tools to kind of condense that down to. But you're going to have several thousand fibers leaving that facility, and you have this facility in New York and that facility in LA, right? And they need to be connected. And that's one of the hidden risks here. So, as a fiber provider, what I can tell you is that we have what are called ILAs, inline amplifiers. Everybody knows what fiber optics are. It's a piece of glass with a little light signal, right? And light is just kind
yeah,
of a sound wave. It's a light signal in a piece of glass. And I'm rounding numbers here. About every 100 miles, we have an inline amplifier. We call it a hut, just a little hut. And all that hut does is it just amplifies the light signal, right? Because the light signal kind of attenuates, amplify it, send it another 100 miles, amplify it, send another 100 miles. Well, we're having to rethink the way we deploy because data centers are implementing AI. And when we look at the number of fibers that are going to be on a long haul route, it's astronomical.
right.
We're changing our deployment technology to meet the data center technology because the hidden risk here is interconnectivity.
Yeah. So to people that maybe don't understand that in the nth degree, like what is the risk then ultimately? What would happen if that failed, if that system failed ultimately?
Sure, sure. So, um, most data center providers or most, like let's just say AI companies or whatever we want to talk about, they're going
Yeah,
to have a main hub, right? And then they're going to have like spokes or edge data centers, whatever we want to call them, without getting too deep into
yeah,
topology. If there's a main compute here and maybe there's storage over here, if you can't connect those two via fiber, then you have a breakdown. All the compute in the world is no good without storage. And all
yeah,
of the
yeah,
storage in the world is no good without compute. And where this really comes into play is you've got compute. And what we use storage for is for folks that, you may or may not understand how deep AI goes, right? But this advanced CPU, this advanced GPU really is for AI, it can't function without what's called a large language model training it. And that's the
Yeah.
data, essentially, right?
Yeah.
So the AI is only as good as the data it can pull from.
Yeah.
So you can't store all this data in one facility. It's just too much data. And when you lose connectivity to maybe there's 5 different storage data centers or 5 different data centers around you, when you don't have that connectivity, your AI output is diminished. And
Yeah.
so the
Yeah.
value of that AI and that tool is diminished without connectivity to the data that it's reading
Yeah,
or
yeah. So
using.
that's so like you said, the data storage as a facility is so important, and because of the the massive advancement and the massive more demand that the data center has, that's where we need to rethink, like you said, the fiber technology, etc., that goes with it.
That interconnectivity is it's on certain folks' radar, but it's definitely not talked about in the industry like
No, you
like
don't hear it.
power.
You don't hear it. Power, water, labor,
Mhm.
geopolitical. You don't really hear about that kind of thing because it's yeah. But yeah, it's like you said, it's a massive part because AI is only going to make it. There's going to be need more data, etc. That's what AI
Sure.
is going to need, isn't it? So I think the technology on that side is going to have to advance as fast as the AI technology is advancing as well.
And that's where we are at Zayo.
Yeah.
We're looking at it thinking like, okay, all right, NVIDIA is not really selling that yet, but they've developed it, so it's on the horizon, and they will start selling it soon. So how do we adapt?
Yeah, yeah. That's where you come in.
Yeah. That's where we solve problems that aren't even problems yet. So we
Yeah.
try to stay ahead of those before they
Well,
become
I think that's
problems.
what the industry has to do though, because ultimately if they don't, you build a facility, 18 months down the line, the technology is kind of outdated, isn't
Oh
it?
yeah.
Almost. So you've got to be thinking where it's going to be in 2 to 3 years because a facility takes 18, 24 months to build, doesn't it, in some cases? So
Mhm.
yeah, I think it's a really good point.
And
Go on.
the reality is in 24 months, you if you build that facility around a technology in 24 months, it's obsolete. I mean,
Yeah,
not
yeah.
necessarily obsolete, but it's no longer, a leading edge.
Yeah, yeah. And if you're investing billions of pounds or billions of dollars into a
Mhm.
facility, you want it as cutting edge as possible when the facility's
Yeah,
operational, don't you?
absolutely.
Yeah. No, perfect. So I suppose how do you make I suppose it, leads us on to you making how do you make kind of design and infrastructure decisions today, given your background to avoid kind of constraints in the midterm kind of future?
See, that's a tough one, man, because we don't have a crystal ball, right? All we can do is look at, everyone talks about the term future proof, and so we talk about that and we look at that. But it's kind of a misnomer because we can't predict the future. We can take an educated guess. So, for example, so in the fiber optic world, all of our gear runs on DC as opposed to AC. And
Yeah,
so, we're going to deploy a plant. And so we look at like, well, we need, this particular hut or amplifier, it needs, 2000 amps of DC power. Well, we will go ahead and we'll use a base plant model that has that can go up to 12,000 amps, and we'll start looking at that. But knowing that we're only going to deploy 4 or 8,000, we leave ourselves growth, and that's one of our new things here in my line of work, my business, my team is anything we touch. It's no longer, hey, I need you to go get me 1,000 amps for that particular site, or I need this for that site. Anything we touch, we don't touch it unless we can absolutely maximize it. And what that means is if I maximized every single drop of power out of this site, I could give you 4,000 amps of additional power or augmentation. And so we won't do it unless we can wring every single bit out of it, knowing that we don't use it today because our funnel, our sales funnel, our growth ramp, they're so sporadic. Like, I mean, I might go a year and not have a single request for 1 extra amp of power, and then out of nowhere, hey, I need 5,000 amps there.
yeah,
It just comes
yeah,
out like so. So we try to build in that capacity. by maximizing the entire site every time we touch it, knowing that we could easily go back at that point and install that load.
Yeah, no, it's really important, like you said, to be fair. So, and from a technology perspective, obviously, technology data centers very kind of interlinked, aren't they? So, what do you see kind of the most impactful as the industry moves forward from a technology perspective?
Well, there's really kind of two things, and I know I don't want to get ahead of myself, and I know what we're going to talk about, right? So, but for this portion of the question, I'll talk about um, AI. That's really what I see now is the hyperscalers are just banging out these facilities. I read an article a couple days ago that there were all these of all the 100, 200, how many ever data centers that were proposed and were submitted plans for, over half have pulled back and have canceled because of power. But part of the draw on that power is the AI. Our equipment is getting smaller and smaller and consuming more and more power. So that AI gear is really pushing us to the limit on just the power it draws. And not only the power it draws, excuse me, drawing that power, we have to cool it. And we're really bumping up against the edge of our cooling technologies here, right? So when we really had to convert to everything had to be liquid cooled as opposed to air cooled, because just you can't change physics, you have to work with it and work around
Yeah,
it.
yeah,
um, and so now we're really bumping up on the edge of the leading edge of physics for water-based cooling, or well, liquid-based, whether it be or like chilled water and chemicals or whatever. But I just call it water-based. So we're really hitting that edge on how do we cool more and more, because at the rate AI is growing, um, we're going to hit a wall very quickly.
yeah, yeah. Well, I think there's so many, like, obviously to somebody like new in the industry, but there's so many components that go into a facility, right? There's so many
Mhm.
different manufacturers, etc. So many different pieces of technology, and ultimately, like for AI to like you said, it's got to be amplified. All the components that go into the data center need to kind of scale, and the technology needs to advance as quickly as AI. And I think at the moment maybe it's not, is it? And I think that's maybe where there's going to be, maybe like you said, a wall that's hit, if we can't solve that challenge, basically.
Sure. And I don't necessarily know what the answer is today.
Yeah.
I'm still solving today's problems. I hadn't quite got to tomorrow's problems yet. That's
Yeah,
that's next
yeah.
week.
Yeah, yeah. And do you think, like, there's obviously talking about the technology side. Obviously, we see, there's obviously, we talked about Texas, we talked about Virginia, etc. Do you see data centers maybe for moving further up north for the cooling side, or do you feel like, power is still more important than cooling ultimately?
Well, that's a great question, because you got to have the power before you need the cooling. It's like
Yeah,
fix you want don't fix the brake pedal before you fix the gas pedal.
yeah,
So fix that gas pedal first and then solve for the brakes. So once we figure out power, then you're right. I do expect that um, we're going to start pushing further and further north. Like part of the problem is, let's just take Redmond, Washington, for example, right? Um, so many data centers. They're already changing the ecosystem. Like all these data centers right along the rivers, that river up there, and they were pulling, they're pulling cooling water out of the river and discharging their I'm going to call it their waste, not really wastewater, but their waste heat water into the river, and they have literally changed the ecosystem of that particular area. So as we think about when we go places, would it shock me to have data centers up in, like northern Canada have a lot of data centers? Not
yeah.
really. Then we have to solve for the communications and the connectivity. But I mean, man, when you're underneath a glacier, you got lots of free cooling, man.
I know. Well, I think obviously, in Europe, it's the same. There's a lot in the Nordic countries now where Finland, Norway, etc., colder climates where they're obviously people are thinking of. But like you said, there was obviously then different challenges. That's what I'm saying. But I think, like you said, the power is the most important because everybody. is still, like you said, everybody's thinking of today rather than tomorrow. But there probably will become a time where, you know,
Mhm.
kind of the today's problem is God, we can't cool a facility, or this, you know what I mean, in the right way, or yeah,
So I'll tell you what I really see is, obviously we haven't touched on nuclear power yet.
yeah,
My opinion is nuclear power is the future of this industry. So I can tell you as a U.S. Navy veteran, we've had nuclear power on U.S. Navy ships for decades and decades. I mean, one reactor is going to last. A soda bottle is enough fuel in a reactor for 30 years or something, some crazy number like that, right? I don't remember all the math behind it.
yeah,
But when you think about a small modular reactor, right, and we're moving that way in the United States. I'm not sure how Europe is moving that way or not yet.
yeah,
But when you look at the small modular reactor, once we really get our hands around that, you have to kind of think about what that means. Everybody thinks that, oh, that means I can just set a data center over here and then I can have all the power I need. I'm not worried about grid tie. That's the key word, but they're focusing on the wrong portion of that sentence. They're focusing on, oh, I got all the power I need and I don't need to worry about grid tie. When they need to be focusing on, we can set a data center over here.
yeah,
Well, where's here? Here could be up north in the cold. And I know I don't want to get involved in all the like the climate change aspects and everything else, but I mean, just for argument's sake, a glacier. It could be somewhere really cold. And then you start thinking about that. Like we talked about building technologies. Well, when you start thinking about, we just said, let's just say an AI pod. Well, why couldn't we put an AI pod in a modular data center and stack 50 of those together and have an SMR nuclear reactor power the whole thing? Now we can literally build a data center in months anywhere in the world. Once we get our hands around the power, we can build it somewhere that it's easy to cool. And then obviously we have to solve that communication issue. But remember, we're now focusing on putting edge data centers in space. So when you start changing your technology, when you start looking at um, microwave communications or satellite communications or whatever that might be, you're completely turning this whole industry on its head.
yeah. What do you think would, how long would you think, like, because obviously a lot of people talk about nuclear power and stuff like that. How and you then refer to data centers in space. How long away do you feel like we are from that ultimately as an industry?
Well, I can tell you that when I left NTT, they had created a whole new division that was solely focused on putting. Now, the word data center, right? I mean, when you talk about putting a data center into a satellite, right? It could be a small data center with small amounts of storage, but the idea being that's step one, right? That's the Wright brothers and Kitty Hawk, and
Yeah,
how quickly can we progress from step one to two, three, four, five, right? So I know it's going on right now, and as far as how quickly could it be viable, I don't know, 10 years, because when we look at Moore's law, every 18 months compute capacity doubles.
yeah.
So when you look at that, and it's not a linear equation, it's very much exponential. So and I think about and I try to guess, but it's just a guess because my gut says it's going to be exponential. We're going to hit that curve and it's going to shoot through the roof. It's faster than we could ever think.
Yeah, well, I think there's already, there's companies out there that are raising, you know, billions and hundreds of millions
Yeah.
to do this. So there's obviously like people, you speak to some people who don't think it's possible. I, I think it's going to happen. It's a case of,
Well,
when it's going to happen rather than if it's going to happen ultimately.
so let's think outside of the box. We all know that NASA just sent Artemis, was it Artemis 3? They just sent Artemis 3 to go around the moon and come back. And the point was, can we do that? Because NASA says their point of doing that was to basically put a manned, I'm going to butcher the technology or the terminology here, right? But a manned substation or base station or camp, whatever you want to call it, to put that on the moon. And when that happens, they're going to need their own miniature data center. They're going to have their own little bank of computers and their own storage and their own satellite slash microwave communications back to the earth, whatever that technology looks like. That's right around the corner. And then
Yeah, I
when you
know,
think
I
about
know.
you've got Musk shooting for Mars, it's going to happen quicker than we think.
Yeah, no, no. And how do you feel that would affect the industry kind of, say on the ground? Like, how do you feel that would affect the industry on the ground? What would happen to these hyperscaler facilities? Would they become extinct, or like, like, do you still think they're needed at that point?
Here's what I can tell you. We talked about like cooling data centers, right? So we touched on that. Well, when you get into quantum compute devices produce an insane amount of heat, and the only
Yeah,
way to really cool them efficiently or effectively is, we have to find the new technology, and we have done that. We've scratched the surface. We know that helium-3 or H3 is the most likely viable solution to cool quantum computing. But we also know that it's I don't want to say non-existent, but it's extremely rare on planet Earth. But the one place that it's extremely prevalent is the moon.
yeah.
And if we can go to the moon, we can either bring helium-3 back to Earth and cool quantum compute, or why can't we
What?
just
Yeah.
build?
Well,
And I don't know the
yeah.
basis yet.
Well, it's like
Can we
anything.
build
Obviously,
quantum compute on the moon?
people are always looking to do things cheaper, and ultimately, sending something to the moon and bringing it back down isn't going to be anywhere near as cost effective or efficient as just doing it up there. So I think,
So when that happens, our whole industry is going to change, right? Once we figure out that we can effectively use quantum computing, whether it be here or there, it's going to change the way we design, the way we build. Now, obviously, there's always going to be the legacy data centers because we still are going to have a bank, a hospital, a government, a business, emails. You're still going to have um, legacy data centers, which is still going to be the lion's share of our industry. But that's going to be leading edge, and that's going to need people that understands it to build it.
yeah, yeah, yeah. No, I think it's obviously like I think the good thing is obviously we're in an industry that's constantly evolving, aren't we? And obviously people like to be yeah, part of that journey. So I think when you start talking about space and Mars and the moon, and it just excites people, doesn't it? Ultimately, so like you said, kids growing up, 20 years ago, they want to be an astronaut. You know what I mean? So it's kind of like, yeah, if people can understand, like, the technology advancements in the industry, hopefully, like you said, it just leads to the industry continuing to evolve and be seen in
Mm,
a better light in the press and stuff like that. Ultimately.
sure, 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 sure. But now, are we going to see that in 5 years? No. I feel like it's very possible to see it in 10.
Yeah. So where so that was my next question. Ultimately, 10 years time, we might be talking about that, because I agree. Like, once we figure all that out, it's not going to be tens of years after. Ultimately, people are going to want to do it faster. They're already doing that now in terms of building these hyperscalers. So where do you feel like the industry's going to evolve in 5 years ultimately, or do you feel like we're just going to carry on seeing facility after facility and just bigger, faster? How do you feel like where we're going to be in 5 years?
Sure. Well, as the industry moves to this place, this position where it's harder and harder to get real estate for a data center, right? Especially your hyperscalers, but even harder to get real estate for, let's just say, a 5 megawatt data center, right? I mean, that I would consider that a normal, realistic data center, right? It's bigger than the legacy data centers, but it's not a hyperscaler. So what's happening, in my opinion, what I see happening is companies that own these, I call them enterprise data centers, where it's like a single company. If you're a company, you own your own data center. The cloud is so much more advanced today than it was 5 years ago, right? So 5, 10 years ago, it was a security concern. And when you start reading the reports coming out of, Gartner and Uptime Institute and all these things, these other agencies, they poll these CIOs and these CEOs. The vast overwhelming majority are planning for a cloud because they want to position themselves for AI. And to do that, they're planning for cloud. And that makes you look at what they're going to do with their real estate if they own a data center. Well, if you're gonna plan for cloud, if you let's just say you're going to put 70-80% of your footprint in the cloud, take that other 20 to 30% and you just put that into a colo, right? And so you're that to me has you looking at exiting your data center. And now you can take that real estate and you can capitalize on that real estate, whether it be I don't think you would really do like asset-backed securities because you're likely going to exit that and sell off that data center to a data center operator. Our large ones, TierPoint, DRT, Equinix, CoreWeave, et cetera.
Yeah.
Exit that real estate and capitalize on that, and then focus on the cloud and or AI infrastructure in a co-location facility. But that's really where I see it's not going to be massive, but as I see CIOs focus on the cloud, my gut says we're going to have fewer and fewer. Again, I call them enterprise data centers as opposed to my simple terms are enterprise data center for a single customer or
Yeah.
internet for like a colo. I see that more and more colos and fewer single customer or enterprise data centers.
Yeah, and do you think that the kind of core architectures of data centers will fundamentally change, or will they just evolve kind of incrementally?
I'm not exactly sure on that one, but I do believe that co-location data centers are going to incrementally change because they're going to become larger and larger, right? So and by incrementally change, maybe there's a campus, and instead of two buildings, it's going to become three buildings or four buildings in
Yeah,
that campus. And for example, like if you go to, I was just in a data center not too far back, downtown Denver. It's what was it like? I want to say like a 1940s theater that was converted into a data center, right? So as real estate becomes more scarce, you see these older buildings repurposed, and it was kind of a cool building. I mean, it had like the old fancy like elevators and stuff from,
yeah,
and so it's not just new builds; it's repurposing old builds, and you're seeing that more and more and more. But as companies begin to exit their primary single customer data center, I see that kind of becoming more and more, and
yeah. Because there is
it's
obviously a massive shortage of, like you said, real estate, isn't there? So ultimately, we know these facilities are large, etc. So yeah, there's obviously a lot of opposition against them, new builds and stuff. So sometimes it's maybe easier to like you said, maybe convert or something like that.
mm,
So and I think you kind of touched on it, but do you feel then we're heading from, you said enterprise hyperscalers, do you feel like we're heading towards maybe fewer of these kind of mega facilities to more of a distributed model?
um I think hyperscalers are doubling down. Now, when we say hyperscalers, we're talking about the Amazon, the Meta, the
Yeah.
Oracle, the Google. There's a few large companies out there that are building the hyperscalers. Um, Now
Yeah,
you
there's
also
five,
have,
there's 8 to 10 companies max in there building these.
yeah,
Yeah,
yeah, there's not that many that are building on that scale,
yeah,
but buddy, when they're building at scale, they're building at scale. When you look at like Stargate, it's got open AI going down in Texas and all the, it is massive. And one of the things that this industry is now drawing outside investors that I never really thought I would see. For example, I think most of us have probably seen um, what's the business show Shark Tank, right?
yeah.
So Mr. Wonderful is apparently actually
I
a
know, I
major
know.
investor in is it, I think it's like
Is it?
northern Montana or something.
Yeah,
It's like
it's
on the U.S. Canadian
yeah, it
border.
was like a month. Yeah, I can't remember the facility, but it's enormous, isn't it? He's the face
Yeah,
of that facility, and it might be like some Montana or something like that. Yeah,
yeah. Well, it's near the U.S. Canadian border, and the idea was they were going to build it on top of a huge natural gas field, and they
yeah,
were going to use fuel cells and natural gas generators, and they were going to literally just draw it out of the ground. Now, I'm oversimplifying, of course, right? But just draw the gas out of the ground to power. And you don't, and the reason they were going to connect to the grid is to supply power back to the grid. Uh,
yeah,
Now that's a disruption, right? But I see very few of those. And I honestly think that we're going to begin to focus. I think a distributed edge model is really where we're going. We're going to have, a number of really large, and then we're going to increasingly see smaller data centers that are connected to the large core models. So
Yeah.
that's just my opinion on where we're going.
Yeah, I think it was in Alberta, that data center. I think it's one of the largest. I think it was plotting to be the largest in one of the largest globally, wasn't it? So yeah, like you said,
Huge.
there's so many. Like if you think of like an Oracle are known as a an ERP company, etc. But now like the investment they're putting into the data center market is probably, I don't know the finance situation, but it's probably as big as their ERP division now. They're
Billions.
yeah.
Well, Oracle just, you have to kind of read between the lines. But when you start looking at press releases and then when you talk to friends that, are affected, Oracle just laid off 30,000 people so that they could double down and spend and increase
Oh,
their investment into their AI facilities, right?
100%. Yeah. But what I'm saying is, like you just said, like fundamentally, Oracle are known as a big oil tank of an ER, a SAP. They're known as a that,
Yeah.
but they're like you said, that money and that is being repositioned into AI and data centers. Like so, the finance that we're talking about now in this market is kind of off the scale. Yeah.
It's billions
Yeah.
are rolling in, and that's just in the US.
Yeah, I know. The US is the biggest market, but I think obviously like Europe, and then you're talking about APAC, etc. It's all over the world, isn't it?
Hmm.
And the final question, like I always try and ask this from guests, but like what do you kind of, because obviously like where do you see like speed or money? What's more important? Is it getting the facility up and running
Oh, it's
quicker
speed,
or speed?
100%.
Yeah,
Because money's not a problem in this industry right now. There are
yeah,
so many. You have all these just like BlackRock and these mega PE firms, and they're just pouring billions into this industry because this industry is very much a whoever gets there first wins.
yeah,
That's the
yeah,
whole, like what in the data center industry, whoever gets there first. And so when you look at these companies that have focused and they've made their name on streamlining a build, it's all about getting there, right? Because remember, we just talked about like if it takes you 2 years to build a building, your building is already outdated by the time
yeah.
you're done. Literally on day one, you're behind the curve.
Yeah, and I think like you said, whoever gets there first is going to win, and I think that's fundamentally like every executive I speak to, it's always speed. Speed is
Mhm.
more important than cost,
Speed, and I
because
mean,
also
and you'll pay for that speed, but it's a business driver. It is.
yeah, but you'll get it ultimately if you don't, somebody else wins, and you're not.
Mhm.
It's kind of that catch 22, isn't it? If you don't focus on speed, somebody else will, and they may spend more in the
Yep,
the interim, but ultimately outside of that, they'll win the race. So like you said,
and
I
they'll win
think
the
everybody.
customers and the
Yeah,
revenue.
exactly. Because I think ultimately the faster you get a facility operational, the customer base is already there, isn't it? There's just
It
everybody's.
is.
Yeah,
It is. I read a report a while back that said for every 1 square foot of data center need, there is approximately 0.75 square foot of data center space online. Like I can
wow.
tell you here at Zayo, like so, we own some of our own facilities, and then we're obviously in third party facilities. And we went to go expand. Like we're in a facility, and we said, "Hey, I need to take this. I'm interested in the suite across the way, right?" And they're like, "Oh, well, that suite is like literally there are 4 people in line whenever that customer leaves, and if you can get in line behind them,
Bloody hell.
yeah, it's crazy."
Well, and that's the thing, isn't it? When I think when you have more again, so it's like that. It's like if you look at one side, you look at the labor shortage, more demand than supply. Obviously, price goes up. It's the same on that side. There's more customer demand than there is supply. Price goes up. And that's ultimately why people are ultimately. It's always money in the end, isn't it? But that's why people are trying to get these facilities up and running quicker.
Generally, but I also, in my view, I look at from a customer standpoint, going to a colo provider,
Yeah.
it's really a commodity, right? It's I'm hesitant to say ubiquitous, right? Because it's not everywhere, but it's all generally the same. And so you have some providers that are literally just buying the customers. I'll give you 10% off, 20% off, just come here, right? Because they know that when they get that customer in there, they're unlikely to move for
Move, yeah.
10 plus years. And that contract, that contract value, it increases the value of their business. So when they start looking at IPOs or anything like that, right? So they're
Yeah,
just buying that business. But it's really a commodity, but it's still very much who gets there first.
yeah. No. Ken, really appreciated your time. I think you've been an amazing guest. I think it's you've talked a lot about where you feel like the market is heading. Some great insights. I think, like you said, nuclear space. It's on the horizon. Who knows? We don't have a crystal ball, but I think the market's certainly in for an exciting period of continued growth, and it'll evolve faster than probably most of us think. I'd say.
Yeah, yeah. Thank you so much for having me. This was great, man. I had a lot of fun. I
Yeah, it's
love talking
amazing.
about this stuff.
I know. Well, yeah, thanks so much for your time. Really appreciate it.